So I'm going to try to guide you guys through the Lab 3. I've got Excel downloaded and open, and I've got the Pearson Stat Lab open. So click on StatCrunch here to the left, and then view datasets from your textbook, Chapter 7. And we're going to have two datasets. 729 is the first one we're going to work with, but you'll need 733 later. So this is 729. You just want to copy all of the data into the Excel spreadsheet. And copying in StatCrunch is a little frustrating. I'm just doing it on the keyboard and then scrolling down. So once you get the comma, Command C or Control C to copy, paste it into Excel, and then name the data. So this data is height of 5-year-olds. So I'm going to name column A height. Those are my data values. Okay. Number 3 tells you to build a histogram of that data. So I selected column A, I click insert, and then there's a menu of charts here in the middle. I want a histogram. So you click there. And then I'm going to have you all figure out later how to add axis labels and to change the bins if you want to, but definitely label the axis. But this is height of 5-year-olds. Okay, so that's the histogram. We can tell that this data is roughly normally distributed. Okay, then in column B, we're going to compute the z-scores for each of those data values. In order to compute the z-scores, we need the mean and the standard deviation of the values in column A. So I'm saying put those values in H2 and I2. So I'm going to put the mean in H2, and I'm going to type equals average, and then I want to take the average of all the data in column A, and the A:A tells Excel to look at all of the data in column A. So then you hit enter, that's the average. For standard deviation, I'm suggesting you put that in I2. You type equal, and then start typing out standard deviation. I'm going to do standard deviation.p because I'm treating this data as a population. And again, I want to tell it to look down all of column A. So those are the two standard deviation values. Those are the two measures of central tendency. One is a measure of central tendency, the other one's a spread. Okay, so I'm looking at number 5 now. Column B is going to be the z-scores. And to get that z-score, I want to compute the difference between the value in cell A2. So I'm going to click that cell instead of typing A2, and then minus the value in H2, except I don't want the cell reference to update as I paste this formula down the column. So I put in $ so that the reference to this cell won't update. So as I paste it down the column, the 2 won't change to a 3 and a 4 and so on. It will always refer back to this mean. And then I need to divide by the standard deviation. And again, I always want to refer back to this cell. So I put those $ there too. So you hit enter, you get this big long z-score. I didn't put this in the directions, but I'm going to go ahead and round this just to the nearest 2 decimal places. The Excel function for that is round, and then comma, and then the number of places you want to round to. So that looks a little bit cleaner. And then I'm going to double click the little box at the bottom right corner to paste that formula down the column. And just to make sure it's doing what you want, you can highlight each cells, and then up here in the formula bar, you can tell what the formula is. So in row 12, this formula is taking the data value in 12, subtracting the mean, dividing by the standard deviation, and then rounding that. And that's exactly what I want. Okay, so those are the z-scores. Then I suggest you skip a column for spacing. In column D, I want us to look at percentiles. And I'm suggesting that the first percentile we look at is the second percentile, so 0.02. And then the subsequent percentiles will be just incremented by 0.02 every time. So I type that into a formula. The cell above it plus 0.02. I'm going to copy that formula and then paste it down a little while. and I'm going to paste down until I get values that are really close to 100. So I want to see all of the percentiles for this data, and I want to go until I get to 98. Okay, so y'all can do that more efficiently if you want to. I'm just trying to give you a feel for what's going on. So those are the percentiles that we want to look at, and that is number 6 in the directions. Number 7 is asking you to generate z-scores for those percentiles, and those are called quantiles, the data values that correspond to that particular percentiles, and I tell y'all to label this normal quantiles. So in this column, you're computing the z-score that matches this percentile. To do that, in your TI-83 calculator, you would use the inv-norm function. Excel has something very similar. It's norm.inv, so this one. And I want to tell it to compute the value associated with that percentile, so in the cell next to this formula. And I'm going to use standard normal, the standard normal distribution. So my mean is 0 and the standard deviation is 1. Okay, so the quantile, the z-score associated with the second percentile is like -2. And that should make sense, or that should make approximate sense if you think about the empirical rule and the standard normal distribution. Okay, and then I'm just going to paste that formula down the column so that I have the z-scores that correspond to each of those percentiles. And notice like the 50th percentile corresponds to the data value of 0. This is like 2.78 times 10 to the -16, so that's close to 0. And that should make sense because the 50th percentile of the normal distribution is the mean, and the mean of the standard normal distribution is 0. So all of those values should make sense. Okay, then finally 8, I'm telling you in column F to compute the data quantiles. And now I'm going to refer back to the data in column A, and I want Excel to look down that whole column and return the data value that represents the second percentile, for example. So that data value is the second quantile, or the quantile that corresponds to the second percentile. That's what I want in cell F2. So the function for that is equals percentile, and if you start typing it, you'll see Excel like auto-completes for you. So I want the percentile associated with the data in column A. So again, I write A through A to tell Excel to look at all of the data in column A. And then I want it to return the data value associated with the percentile in cell D2. So I click on cell D2 and then close the function and hit enter. So the second percentile of data is something like 35.4. And if you look at the histogram that you made earlier, that should kind of match up with what you would expect. So 2% of the data is to the left of 35.4, and so on. So you can paste that formula down the column again, and you get all of the data values that are associated with those percentiles. And again, just to check, let's go to the 50th percentile. That's telling us that the middle value, the median of this distribution is like 42.25. And again, that matches up with what we expect from the histogram. And it's really close to the mean too, which we would expect for normal data. Okay, so that's all of the Excel functions, I think. Now I'm just telling you to generate 2 scatter plots. So the first scatter plot I want is of the raw data versus the z-score. So highlight columns A and B, go back to insert, and I want a scatter plot. So click the dot thing here and insert a scatter plot. And again, what I want y'all to notice here is that this is linear. And it's going to turn out that this plot will be linear no matter how the raw data is distributed. And since my z-scores are on the y-axis, this should be z-scores versus raw data. If it was flipped, the graph would still be linear, right? So that's what I want y'all to take away from this. And then the second plot that I want is the actual QQ plot. It's of the normal quantiles associated with the percentiles against the quantiles from the raw data. So again, you just highlight those two columns, make a scatter plot, and this scatter plot looks approximately linear. That's because the original distribution of data was approximately normal. And so this is my QQ plot. This is data quantiles versus standard normal quantiles. Okay, so I'm titling that appropriately. I would like for y'all to go through and refine these plots a little bit. So for example, I don't need the x-axis to be this long, especially in the z-score versus raw data scatter plot. So if you right click on the axis, you should be able to format the axis. Let me see if I can get that. So I selected the axis, right click. I don't see that it's letting me do that. There we go, format axis. And you can set the minimum to be something closer to what the actual minimum of the data is. So I can set that to be 0, and the maximum looks like it's maybe like 50.5 or something. Okay, so maybe the minimum is closer to 34, something like that. That'll just make the plot look better. I'll let y'all decide how much effort you want to put into that. But I do expect you to label these axes, and you can figure that out using Google or just clicking around. I want to leave something for y'all to figure out by yourselves. So that piece is making the graphs look good. Okay, so now that we've built a good Excel spreadsheet, you can copy the spreadsheet. So right click on the sheet 1 down at the bottom, click create a copy, and then the spreadsheet will be duplicated. So the original one is in sheet 1. I'm going to rename that to be normal because these were the plots, the QQ plots for normally distributed data. Now if you go back to StatCrunch, the second data set from 7.3 is not normally distributed. And what you'll notice is that the scatter plot of raw data versus the z-score still looks linear, but the QQ plot will no longer look linear. So I went too far here. I'm just trying to copy the data. That's probably good enough. So the way this works, because we built this spreadsheet appropriately, if I paste this data over top of the old data, everything should update automatically. So that's what I'm going to do. And you notice that all of these plots changed. Because I changed the axis here, it didn't automatically update, but we can go back and do that. Format axis. And so I can make it automatic, and there you see the data values. Again, make sure that you update this data label. That's not height anymore. For the 7.3 data, it's waiting time. And so you need to label column A appropriately, and then also label the axis of your raw data. The x-axis needs to be labeled waiting time. But you can see that because this original data skews right, the QQ plot does not look linear. And that's the takeaway. If y'all have any questions, feel free to email, come to office hours, whatever. Hopefully this was helpful.